So my name is Mark Downey. I'm application engineer with GoEngineer, and I formerly Design Solutions for those of you who were in the first presentation and get to hear this. Where are you going to get a repeat? I've been using SolidWorks since 1997. I got my Bachelor of Science in Mechanical Engineering from the University of Missouri. Grew up in Kansas City. Kansas City, went to St. Louis for McDonnell Douglas, worked there for a few years, and from there to Ohio, worked for the automotive industry for a while. From Ohio to North Carolina, where I worked for Weldment for a few years, and then Weldment, I went to work for a reseller in '97. I worked for a SolidWorks reseller back then for a few years, and then from there I went to work for an extrusion and injection molding company in North Carolina. It was called American Extruded Plastics and Injection Molding. And then from there to Hunter Douglas out in Arizona. So I moved around a little bit. Spent 14 years out in Arizona doing custom shutter design for Hunter Douglas. So been using SolidWorks, like I said, since '97 in all of those industries. The RevWare was the solid partner that Design Automation created, which was a reseller. It was reverse engineering software. So since '97, I've been using SolidWorks with extrusion and injection molding tooling, and then with shutters as well. So a little quick summary of my background. I do have my CSWE. I'm also certified PDM, an admin, certified instructor. So a few certifications out there to help people with. Back August of last year, my wife and I got the last of our 4 kids off on their own, and we decided to escape to a farm that we inherited, that I inherited up in Northwest Missouri. So I've got 188 acres up in Northwest Missouri, in the smallest county in Missouri, Worth County. My wife and I are out there trying to restore it. My grandfather and my father were both raised on this property. So my wife and I are now there trying to bring it back up to its original glory. So it's kind of fun. So what we're here today to talk about is Weldments. What I'd like to do, and I use Weldments in the shutter industry to do the frames around the shutter, because each shutter is custom, and I used it for wood. Obviously, Weldments are kind of for metal, but I'd kind of like to get an idea of what you guys are using it for a little bit, and kind of help me make sure I cover some of the points. So, are you using Weldments? Oh, Larry, you're new to using SolidWorks, so
I'm new to this.
You haven't even used it at all. What about you for Weldments? No Weldments?
Chassis design,
Chassis, okay, cool. You guys?
tanks, stainless steel vessels, stainless
Okay.
steel assembly,
Weldments for that?
perjury.
Okay. Anybody else using Weldments?
Custom trailers and smokers.
Okay. And you're using Weldments for that now in SolidWorks?
Somewhat.
Somewhat? Okay.
Okay.
What kind of challenges are you up against that you're hoping to get today?
A lot of the challenges that we're seeing right now with the smokers being barrel shape we're going on right now, where we designed SolidWorks as a cylinder, but in reality there's flat spots, and so when we get out to the floor and get into the assembly process and the welding, and the fit up is not always what you would see in theory and some
Furniture, structures for like industrial type stuff. Then any combination like sheet steel and tube structures.
So you're doing a combination of weldment with sheet metal over the top of it, stuff like that.
And custom trailers too.
Who was at the last meeting we had? What was the name of the meeting we had last time?
CATI.
Anybody go to that one? Hey, that's big Weldments up there. It was big Weldments. So I imagine you didn't said it. So like I said, I've used Weldments for wood. I haven't done a ton of Weldments. So I'm hoping to facilitate some discussion here. I'm going to show some stuff that I've done and some of the tips and tricks I think I have. But if you've got any questions during it, feel free to raise your hand, ask, stop. We'll go into that. So I'm going to look about. I'm going to talk about some of the basic stuff. If you haven't used Weldments before, and I know some people are new to SolidWorks, I'm going to talk about setting up a folder structure. I know it's kind of basic. I know it's kind of weird, but when you're doing Weldments, when you try to set up for the first time, the folder structure is kind of tricky to understand. So I'm going to talk a little bit about that. I'm going to show you how to do the shutter frame a little bit with a quick moment on that. Structure system, is anybody familiar with structure system? It's brand new in 2019. I'm going to be demoing in 2020, SolidWorks 2020 today, and show you some of the stuff with the structure system. It's intended to make weldments easier. In the task pane on the right-hand side, you get the option, out of the box SolidWorks comes with a very basic set of profiles. We'll show you how you get a full set of profiles in the task pane. 3D sketches, a lot of weldments are better done with 3D sketches. I'm going to show a couple tips for how to maybe make 3D sketches a little bit easier to use. And then we'll have, if there's time, I'll have a little bit of discussion about weldments and PDM. Does anybody use PDM for SolidWorks? Okay. Just a little bit of tricks with using PDM and weldments. So we'll talk a little bit about that. So setting up the folder structure. When you set up a weldment folder in SolidWorks, when you start a weldment, it's got 3 drop downs that you have to fill in. The first one is the standard, and that, when you look at the illustration here, it's looking at a folder. So the top folder is the weldment profile. Then the subfolder is what's going to fill in the ISO as your standard. Then the folder below that is what fills in the type. And then the size is the actual file size. So the default location for this is going to be under your program folder, SolidWorks 2020, language English. That's where that default folder is located. It's a little bit of a nuance though if you use configured profiles, and I'll show you this when you download the files when you click on the link, you're going to get a configured folder that goes right straight into a library feature part. And in that situation, when you click on the type, you'll notice it says configured profile. It gives you this file feature here, this library file part, has configurations in it, and that will populate the size. So there's a little bit of a nuance when you're setting those up in the folders. So ANSI configurations here, this is a configured part, and let me drop this over into SolidWorks real quick. Maybe. Windows Explorer is best laid plans. So that folder location again I mentioned is under I've got a folder location on here that's my SolidWorks weldment profiles, ANSI configuration. So when I open this weldment profile, you'll see a list of configurations on the side. So for it to be a configured profile, it needs to have these configurations listed over here for it to work without the subfolder. If I look at the subfolder version, down here I've got a wood profile and then a hardwood profile. So there's two levels there. So these files here don't have configurations in them. So you have to set those folders up a little bit differently, and it's a little bit tricky to look at that. Notice there's no configurations in this one. So something to look at. There's just, whether you got configured files or non-configured files, there's a little bit different setting that up. So let's take a look at this shutter frame. I'm going to start out with just a sketch, and I'm going to go over to the Weldments tab, structural member, and then here's that list, that list that you're looking at. So here you can see the ANSI configurations. I've got one down here, it's called frame profiles, and then the type is Z-frames, industry terminology here, and then colonial Z-frame. So you pick your profile that you're wanting to use, and then you have to go in and select your groups. I'm just going to select the 4 sides, and you can adjust your corner trims as needed. Zoom in here a little bit. So there's what that, so this is a non-uniform profile. It's asymmetric. And so sometimes when you bring an asymmetric file in, it may not come in exactly like you want it. So if you can think about a shutter frame going into a window, this is what goes into the window. This is the part that goes into the window, and this is the decorative flange part of it. So this would come in correct. This is what it would look like in the window. This is how I'd want it to be positioned. But let me go over and change this. I'm going to edit the feature, and I'm going to click a different frame profile I've gotten here. If I go to a top-down view on this one, the decorative portion of the flange is on the it's on the inside of the frame. So I want to flip it around. So the way you do that when you're editing the feature is down here at the bottom is you got an option to mirror the profile, and you can see a couple different orientations. There's two ways to orient it. You can see the decorative feature here on the back. I want that on the front. So instead of mirroring about the horizontal axis, I want to mirror about the vertical axis, and that gets the decorative feature to the front. So that's how you would, if you get a asymmetric, the way you draw your profile may control how that comes in. Does that make sense? Structure system. So this is the new thing in SolidWorks 2019, and again I'm using 2020. The way the structure system works is you can use sketches, planes, faces. So this is a demonstration. This is actually off of the GoEngineer website. I borrowed his concept on this. You can see there's 2 sketches. There's a sketch at the bottom, and then this vertical sketch here. There's an axis that's used to define the angle of this plane, and then a couple of other planes, and then another reference plane, and I'm going to show how this works. Structure system, if you don't have it turned on when you right click, and this is something new to 2020 if you haven't seen this yet. Before in 2019, when you right clicked on this, you'd get a list of tabs. Now they've got it consolidated into a tab folder. So when you click on that, then you'll see the list of command manager tabs on the side. You have to have structure system turned on, and you get the structure system options up here. You click on structure system to turn on, to go into the structure system command, and I want to click a primary member. Here's the different types of primary members. You can do a path segment. You can use reference planes. You can use points. And you can do intersections between faces and planes. I'm going to start out here and use the point option. And I'm going to use the up to plane. I'm going to go around here and click. For the points, I want to click these bottom corner points. And I want it to go up to this plane. And for the reference axis, I want it to go along this axis here. Now, notice nothing happened. I need to select a profile. So I'm going to go over here and click on my standard. I'm going to go down to ANSI inch. And I'm going to use square tube. Actually, let's go to ANSI configurations and let's select aluminum square. Aluminum tube square, and let's go down here and grab a 3-inch. Notice this list is quite a bit longer. I'll show you how to get this list in a few minutes. So let's go down here and grab a 2-inch square with an 065 wall. So notice those tubes popped in there based on those selections. It used the points for the location of it, and then it took it up to the plane. If I go back over here to the member and let's clear this selection for a second. Notice it's trying to go perpendicular to the plane. So I can use that sketch line to drive the direction of it. Okay? So there's a little pin icon up here at the top. That pin icon is used to lock it in place because I can do multiple features across this now. Let's do a point to point. I'm going to use the point down here. I'm going to say up to a point. And I'm going to pick this point down here in the corner and up to this one. I'm sorry. I'm going to pick my reference points to start, and then the up to point is this point up here at the top. So I can bring all those up to one point. So I'm not having to create sketches for this. Notice I'm doing this all with, I have to create sketch lines for each of these paths. I'm using geometry to be able to do that. Okay, so then those are primary members. Notice there's a primary member and then there's a secondary member. Secondary member is where I go in and create secondary members between these geometry. And I'm going to do between members. And I'm going to select this link icon to go between these members here to here. So it linked those selections together. I can tell it to set that off at a distance, or I can have it at a length ratio. Length ratio meaning how far from each end. I'm going to go 50% on each of those. So notice it's going 50% from that member to here and then across. One of the beauties of the structure member is once you exit out of the structure system, it goes into a corner management mode, which is where you tell it how to trim the corners. And depending on the types of corners you've got, there's tabs across the top. There's simple corners, there's two member corners, and there's 3 complex corners. And you go through and manage each one of these as you need. You can let it go automatically, or you can control it individually. If we just go ahead and let it do its stuff, you can see here that didn't quite trim it like I wanted it to. And you look at these corners down here. So it automatically trims the corners to some extent. You can see that kind of got complicated up here in these corners. So if we go back in and edit the corner management, we can select the corners. You can see the dots at the intersections. If we click on those dots, then it shows us those components in there. We want to use a full contact trim for this one, so we can go in and manage those corners. Let's go over here to the complex corners. We'll go in and see what we can do on this one. On the complex corners, you got some options up here for corner treatment. You can do the trim tool. Now let's say we want this to be the trim tool. So I'm going to click on that component in the graphics area, and I'm going to shift that one up to the top. So now it's going to trim these two to that one. And when I exit the sketch there, you can see how it trimmed each of those to that part. So that's a quick view of structure system. Question?
Can you add a gap? Like
Yes.
I believe a 16 gap for welding.
Yep. So if you notice in that corner management, if I click on this corner again, let's go to complex corners. Here's the gap down here. It looks like complex. I don't have the option for doing the gaps on the complex. On 2 members, here's the gap down here for setting that gap. So it looks like on complex members, it doesn't give that option. Marcus, do you know?
I was going to say, click the dot.
Oh, corrected. So once you activate that corner, it does have the option to do the gap there. Yep. Any other questions? This takes some time to get your head around. I'm still working on it, to be honest. I mean, it came out in 2019. You have to put some forethought into it because you've got to lay out where you want your center points to be ahead of time, where you want your intersections to be. So if you're setting up planes and surfaces, there's a little bit of planning besides just setting up a sketch. So that's a quick introduction to that. One of the other things about that I want to show real quick is so here's a completed version of that shed. One of the neat things about the structure system with 2020 is the ability to mirror the structure system. So if I wanted to mirror this whole system, I don't have to pick every body. This is a multi-body solid, right? It's got a cut list over here on the side that's got all the bodies in it. If I bring an offset plane over here, and I go into the mirror command, bodies to mirror, there's a new option down here for structure systems. I can click on this structure system option and mirror that whole structure system, and it creates a new structure system that I can create new components between. So if I want to add a new structure element between there, if I go over to structure system and I want to create a secondary member, it recognizes this as a structure system, and I can go in here and set the length to be 1 to 1. So it recognizes that new component as a structure system with the mirror. So that's a really powerful capability. You can see it can be pretty easy to create a pretty complex weldment with just a little bit of information. And then it goes into corner trim again and trims that corner automatically. So I talked about out-of-the-box SolidWorks, which comes with a limited amount of tools to use, a limited amount. You can get more of them by going to the task pane under Weldments. You'll see this ANSI inch zip. When you control-click on that file, it'll download a zip file. Once you extract that zip file, it gives you all those folders that I was showing you a minute ago. If I bring up File Explorer again, and I go down to my Weldment folder. These are the configurations that you'll get if you download each of those folders. So if you look back over at the, there's ANSI inch, AS, BSI, DIN, all these standards, Unistrut. When you download those, you can extract them, and that'll give you all these configured files to use as Weldments. So you can expand your library by going and getting those from the task pane. Okay. So 3D sketches. They're a challenge to use. Anybody ever used 3D sketches? Yeah, they're kind of tricky to use, right? I Googled this picture early today, and when you create 3D sketches, a lot of times it's good to have reference sketches. So each of these reference sketches were used to constrain the endpoints of the 3D sketch. So, I'm not going to go into a lot of the detail about 3D sketches, but they're a little bit tricky to use. When you sketch in 3D, you can toggle between planes. You can create references to external sketches like this. So that's kind of the easy way to do that. Another way to create geometry is using intersecting sketches. This is one that, if I roll back in here, you can see this curve, and this curve is created by two sketches. I've got a sketch that is just a curve on the top, and then a sketch that represents the parabola on the other side, and then I did an intersection. So when you intersect those two curves, you get that 3D geometry that you can sweep something around. So that's a way. If you know what it looks like in two different orientations, you can sketch that, project those two together, and get a composite curve that you can use for geometry. And then I just did a sweep to join those together. Let's take a look at 3D sketching. So to get to 3D sketches, you go to your sketch, 3D sketching. We'll start a line. You get a little bit of information when you do this. As you start to sketch, you see the XY next to the cursor. That's telling me I'm in the XY plane. You can toggle between those by pressing the Tab key, and now it's in the YZ plane. Press the Tab key again, and it's in the XZ plane. So you can toggle between those orientations by using the Tab for sketching. And you get your inferencing lines as well. So when I dropped that there, it created a long Z constraint in there. So using the Tab key to toggle between the planes and looking at your inferencing lines makes it a little bit easier to create those sketch elements. But you kind of have to think about it a little bit. You have to know, I'm tabbing between my planes, I'm changing my reference planes. Here's a little trick that I picked up a while back. I'm going to create a surface and use that surface to create my weldment. So I'm going to start on the top plane, and let's just do a center point rectangle for simplicity purposes here. I'm going to go to surfaces, and I'm going to extrude a surface up. Now the nice thing about surfaces is there's no mass to it. So it doesn't. If I'm using this to create my weldment, it's not creating additional mass in it. If I extruded a box, then that would be mass in my model. But using a surface doesn't do that. I can now use this to create with the structure system. I don't necessarily have to do this, but I'm going to show you how, if you don't have structure system yet, how you can create a 3D sketch real easy using this geometry. I'm going to go over to sketch and start a 3D sketch. And now I'm going to pick each of these edges and do a convert entities. So I now have a 3D sketch driven by that surface geometry that is without having to go into 3D sketch and draw each one of those. So I can create it a little bit easier using 2D geometry and then convert those edges to create the 3D geometry. Boxes or rectangle is a pretty simple example, but hopefully that conveys the idea. If you had a surface, a curved surface, you needed to get geometry on that and do similar surface. Any questions about that? Does that make sense? Yeah.
Have you ever had where, so a common thing that I use convert entities a lot of times is they don't update all the time. And so you lose, it does happen, I mean, 90% of the time you update, but 10% of the time when you really need to update, it loses.
You really need to. It's not hard to say. I mean, I would have to see what was going on with that.
Yeah.
But yeah, it's something to watch out for. Anybody else have any experience using this? Is this new to anybody? This idea? With the structure systems, as I mentioned, you don't have to do this. With structure systems, I'm going to delete that sketch. I can go in and create primary features using that geometry. Let's click a profile here. We can still have a square. It recognizes those edges as sketch edges already for me. So I didn't have to create any sketch elements. I'm using the actual surface boundary to create the geometry with. So if you can create a surface to get you what you're looking for, then you can use those edges for sketch geometry for your weldments. And then once you're done, you can hide the surfaces to get your final weldment. Let's talk a little bit about managing these in PDM. If you're doing weldments, I guess let me ask a question. When you do weldments, do you have to set them up? Are you setting each of your components up as individual parts, or do you manage? You do. So you have to. Each part has to be controlled individually.
Each part is an individual part.
So that makes it a little bit of a challenge, especially if you're trying to use PDM, because SolidWorks PDM is going to recognize that part file as a file by itself. And so your individual bodies inside can't be split out. It's not something, the only way you can do it is to save bodies. You use the save bodies command, and that'll save all those bodies out as separate part files that then can be managed. And then so your master file is your part file, and then all your components will be driven from that. So that's the way to get it. That's the way to do it. If this is that frame sample I had earlier up here on the screen, and one of the things about weldments in that is under the bill of material, once you've created a weldment, you can get a weldment bill of material which shows the total usage of each component, or you can get a weldment cut list which shows the internal weldment cut list in the BOM. So you can get that from the part file in PDM, but you're not going to get individual parts unless you save them out as save bodies. Anybody else using PDM for weldments or anything like that? Marcus, you got anything to add on there? And I guess I open it up for discussion at this point. That's really all I have for tips and tricks at this point. Are there anything anybody wants to see? Any questions that we want to try out? And this is supposed to be a user group. We're supposed to all be helping each other out. So I kind of facilitated some of this discussion. And did I bring anything up that anybody wants to see any questions on? Or? No?
I'm completely new to it, but what if you didn't want to use anybody's standards for your weld profile, but you wanted to create a very specific profile for the weld that you want to call out? I guess.
Great question.
Maybe that's a simple thing. But
There's some steps involved with it, so we can take a look at that real quick.
Weld or structural shape?
The actual weld.
The weld itself?
Yeah.
So I want to create my own profile. Let's.
He's talking about the welds themselves.
Like the actual weld.
Oh, the actual weld.
Yeah, like I have used it, but I'm guessing that your ANSI and JIS and all that is going to kick out a certain profile for the weld to relate to the material that's behind it. No.
No, it's just a profile. The weld bead itself is you control your welds.
As soon as you just use it super glue.
Yeah.
Okay.
Yeah. There's a way to add weld beads. I wasn't prepared to get into that, but there's a way to add weld beads into the model. You need to show those.
It's a separate feature.
It's a separate.
And you can go in and you can say, this is a skip weld, you grab it and say, like a square tube, you can say, propagate tangency, you grab the whole perimeter of contact of those tubes, find the middle of it, and then you can call it out as contiguous on the side of it, space from the end, a certain distance, however, and then it creates the weld zone.
And it's actually creating bodies in the model.
Well, there's two of them. There's a fillet weld and there's a weld bead. Weld bead is in the annotation. It's kind of like this cosmetic thread. Cosmetic thread is not actual machined threads. It just looks like it. A weld bead is a visual reference that shows where the weld bead would be, but it's kind of a made up.
It's fake.
It's fake. Right. But that then can be put into a table. You can say I've got 15 welds. Weld number 1 is this call out, right? And that creates this much weld. You can actually cost it in there. You say I've got 87 feet of weld. Total, the weight per weld, cost per foot, inch, whatever, set your units, set your values, and use it for estimating or for call out. But it can be done on assemblies, weldments, non-weldments. It's a separate feature.
Is it possible to produce a drawing for each cut list item from a weldment?
A couple different ways to do it. One would be to save bodies and save them out of separate files, and you create drawings for each of those. You can also hide and show bodies in the feature tree, so you can create display states for a weldment that shows each of the components, and then use the display states for drawings. So let me demonstrate that real quick.
There's also model view and relative view. You can choose bodies from the drawing environment.
From the draw, okay,
Yeah, let me show you.
sure.
Can you make a drawing of a weldment?
I have a drawing of
Shed.
a Open.
And you can literally just throw it.
I've got one ready to go. I just need to get to it here.
And so, what you're saying, the display state or hide show bodies or whatever, this workflow does that, but it's sort of from the drawing environment.
Okay. All right. So here's that weldment of the frame.
Yeah. So go to the drawings. First do a model view.
I'm sorry.
Drawing tab up there at the top. Do a model view.
Model view.
Usually that's like the one everybody uses, and usually at this point you just click OK or you drop it. But if you hit Next instead, and then down there see it says Select Bodies under the configurations, you get to go back to the model and say, I want only this one. You grab it, click OK, you now have a view as if that was the only body in the entire part. You can project it, you can do anything you want with it. That's a part, but it's actually just a body from the part.
Yeah,
Cool.
say for instance, that frame right there. I would create 2 drawings,
Yep.
quantity 2 each,
Yep.
hand it to the guy, he'd go back to the stock rack, grab the material off the stock rack, walk over to the saw, and cut it at whatever angle the drawing tells and whatever length. So,
And you can put the angle cuts in the cut list, or you could detail it in individual views. So like sheet 1 would be the first piece, sheet 2 would be the second piece. You just create views as if each one is the same.
so 1 drawing, 2 sheets.
Or 2 drawings, 1 sheet each, over a view. The other one is relative view, and it's not on the drawing tab. So it's one of those secret drawing commands. This is where I like using the S key usually. So hit the S key and type relative.
I guess I got a spot right.
Yep. There you go. And it works the same, except what if those weren't orthogonal? What if there was an item in there at a 30-degree angle or cross member, but you wanted it to cut it on the saw straight? You didn't cut it on the saw 30 degrees off, right? So you want to put it on your drawing 30 degrees off. So with the relative view, you pick your bodies, but then you pick your orientation. And this one may be a bad example, but see where it says either front or right, or front top, or front bottom? You grab 2 references and say, this is what I want to call the front of this piece. This is what I want to call the top of this piece. And then no matter what orientation it is, even if it adjusts later with design changes, it'll always show flat. Drawing with cuts just exactly.
Cool.
Those 2, if it's orthogonal already, model view will get the job done. Relative view will take a couple extra steps, but it has that orientation aspect to it. I had customers that would do the hide show bodies, but then they would change the size of the frame, the cross members would change the angle, and their drawing views would go angled, and they were constantly trying to fight that. So it's relative view.
I love being able to share this information. Thank you, Marcus. That's terrific. That's terrific. All right. Well, as I mentioned, I live on a farm. We set up a live catch trap, and we caught a raccoon. And I'll tell you what, raccoons are smart. They were actually able to get out of the cage. So, you guys see his eye popping around the corner there? He's actually reaching around the end of that door and grabbing a hold of the flat. There he got out. Look at that. And we figured out that he spread the word. So we moved the trap. So you can see it in the picture there. See that raccoon's caught in the cat? We got it set sideways. Watch this guy. Look at him reaching around there. He grabs a hold of that bar. Watch. He pulls it right open. I'll tell you what, raccoons are pretty smart.
Damn Missouri raccoons. When I lived in town, we caught 7 of them last year in the city limits.
Wow.
Now, if you reset the trap, that would
We've got another one where the raccoon got in the trap, and the next thing you see popping over the back is a bobcat. And the bobcat's sitting there looking at that raccoon, and you're trying to figure out how to get to him. So Anyway, thanks you guys for your attention. I hope you picked up something new. And thank you, Marcus, for the additional support.